Okay, hello and welcome to this PHP security tutorial on including files. The problem I'm going to talk about here isn't actually to do with including files directly, it's more the problems that come up when you allow the user to control which file is included. Although I suppose that's true of all my other security tutorials if you think about it, so yeah. So anyway, to demonstrate the problem I've got these two files here. This is basically a very badly written simple template system. So what we've got is bad file, that would usually be like your index.php, and then we've got page, which would simulate sort of the page, you know, the content that goes into the template, which would be in bad file. So I'll just demonstrate this briefly as well. So if we go to our code, you can see what we've got is a simple check for a variable, and then we just include that entire variable. So then by browsing, well, I've got to open my browser as well, but just reload that. Ignore that. By browsing to this URL, badfile.php, and sending this get variable page, we can just include page.php. And that works fine. Oh, by the way, this is just a timestamp. I needed something to output, and I've closed it. And display and echo time seemed like a sensible thing to do, just to have something on the page that will dynamically change. I also considered random numbers, but decided against that. There you go. So yeah, this is just a timestamp, and this is just, like I said, including that file, which is demonstrated by this output. Now the problem here is that obviously whatever is here in this highlighted bit is included. It's sent into the include sort of function. So if someone were to, for example, type in etc password, they get this, and this is not something in our folder, it's actually a file on the server, and this is a list of all the system users. If I just view the page source, it'll be a bit clearer what's happened. Just scroll down a bit, and we get makes it a bit bigger. Not that the list is that important. So this is like a full list of all the users that have accounts on my local test server. So you can see that, well, to be honest, this is not that useful to, well, any of you, because you can't get access to my server anyway, but it does demonstrate quite nicely that this sort of vulnerability allows people to include random files. Now the more sort of, I don't know, the slightly more serious problem, I guess you could say, is that this same exact problem also allows someone to execute like random PHP code. So they could potentially like get your database passwords, or delete your entire site and database, and just send emails to everyone, advertising, spam, all kinds of bad stuff that you don't want to happen. And the reason that is possible is because the actual web server makes a log each time a request is made for a site, or for a website, you know, a page. So this string here, this whole URL, will be logged in a file somewhere. And so, for example, if someone were to make a request for like something like this, obviously the file is not found, but actually this highlights the other problem. Good. The file is not found, but this whole string would be written to the file, and assuming there's no other PHP code in that file, because usually they're like tens of thousands of lines long, assuming there's no other PHP code, if you include that file using the vulnerability demonstrated previously, when PHP gets to, well, finally gets to this PHP, little tiny PHP bit here, it will execute this as PHP code. And you could have this like include another file, well, suppose evaluate another file, another string from like your server, so that'd be a bit easier to sort of start messing about with it, but something I'm not going to demonstrate fully. Oh yeah, that's something I'm not going to demonstrate fully, because when you can't do this just with a browser, because when the browser makes a request, its URL encodes everything. So you can see that instead of having, well, this page not found message demonstrates this quite nicely, because instead of having the actual, you know, this actual string, we have this sort of weird percent encoded thingy, and this string here is what will actually be written to the file when you request via the browser. So to actually make this work, you have to open a telnet connection using a terminal and request like that, because that won't URL encode anything. That's why I'm not demonstrating that, because it's quite a faff, and to be honest, it'll just get confusing. But it is possible. It's quite a common problem as well. So yeah. So yeah, if we just go back to our broken page, I'll show you how we can fix this, and also demonstrate a way that you shouldn't fix this. So what we're going to do is, what we need to do, sorry, is check to make sure this is sort of available. It's valid. There are a couple of ways that are sort of commonly used. One way is to make sure that the variable doesn't have any slashes in it, which to be honest is a bit of a crap way. I'm not entirely sure if there's any way to sort of bypass it. Not that I know of, but I don't know everything. Nobody knows everything. That'd be impossible. But it feels like there would be to me. So yeah. Another way is to, well, the way I'm going to show you is to check this against a list of sort of valid values for this variable. So yeah. Okay, so what we need to do first, before we do that, is demonstrate the bad way that you definitely shouldn't use. So what we're going to do is create a new folder. I'm going to call it Pages. I'm going to drag this page into the Pages folder. And if we go back to our code, what you might think would be fine to do is to add a file exists check, like so. It's a perfectly sensible thing to assume, but unfortunately it would not work. Well, it would work, it just wouldn't be very secure. So what we're doing here is checking if the file that they supply exists in the Pages folder. That's not exactly what we're doing. What we're checking is if this whole string exists as a file. So if we were to, for example, just above do echo this, so if I just copy that and do echo this, go back to our browser, hit reload. Oh, I spelled file exists wrong. How disappointing. Okay, file exists. Go back to our browser again, hit reload. So now you see what we're checking for is pages with the slash and then slash etc password, because that's what's supplied. So if we were to, for example, just do page.php, oh, okay, I need to change the include line. What we're checking for now is pages/page.php, and that does exist. So just going back to our wrong tab. I just need to change this as well. Hopefully it's still, yep. So that's now including the file from the Pages folder. So just refresh this again. This apparently works because this is the output from our include, and this is just the output of the echo line. But the problem with this is that you're still allowing the user direct control over the file path. So while doing stuff like this, well, spelled wrong, and with a missing slash, won't work. You can still do, damn it, not enough of these. There we go. You can still do that, and that will still work. The double dot just means up one directory, so you're going into Pages, then up one more, then up one, so back into the root, and then up again, up again, up again, up again. And you can just add as many of these as you need, basically, and then you'll end up at the sort of root of the entire server. As you can see, this list of users has still appeared. So this demonstrates that this method is not secure. Now getting on to the way to actually do it, obviously there are more than one way to actually secure this, but my favourite way, it seems the most foolproof way, is to list the directory and then check if this variable is in the directory list. So to list the directory, we just use the scan dir function, and just to demonstrate what this outputs, if I just do print _r of scan dir of pages, and we will just go to something that won't give this weird output. Okay, ignore this error. But okay, so the scan dir function, what this outputs is a dot, a double dot, and page.php. So this basically is a list of files that will be allowed to be included, because this going back to our code, this is just written in PHP directly. There's no get variables. The user has no control over this list. meaning that the only thing they could do is include another page. So if we just use this as a list of allowed pages, we can just cut this, delete those lines, replace this file exists check with an in array check. What the in array function does is it checks if the first parameter is in the second parameter. The second parameter has to be an array, and the first parameter can be basically anything. So the first parameter is just going to be get page, and the second parameter is going to be the list of files in the pages folder. And then we're just going to be including pages page if that is true. So going back to our site, we can just hit refresh. So we get a blank page for this because this page doesn't exist in the pages folder or that array I just showed you. But if we were to do well, etc password, also blank page, or the one with loads of up A levels, also blank page, or we could do page.php, pages included. So basically, because we are checking what they supply against a list of valid things that they could supply, and this list is being generated dynamically, there is no way that they can sort of really get around this. One slight problem is that they could include a dot, which would give this error, but you could also just check for is file. So to prevent that, you could just add after in array, you could add an is file. Well, that's the file path, so pages / get page. The right type of bracket, hit reload, error has gone. So now that has prevented, because the dot and the double dot are in the result of scandir. So yeah, that's basically the end of this. Hopefully you've learnt something a little bit and you will remember this method. So yeah, thanks for watching, and don't join me in part 2 because that doesn't exist, and this is the end. Okay, goodbye. With sign off.